Hi, and welcome to my special edition of the non existing podcast that I will call for the occasion The Right to Answer. My guest today is Chad Sakac, Senior Vice President for Global Pre Sales Technical Resources at EMC. Welcome, Chad.
Hans, it's great to be here, man.
Chad, tell me shortly, what does that mean? Senior VP Global Pre-Sales Technical Resources.
Any technology company has a role that they call it different things. Most people call it an SE or a systems engineer. These are the technical people that work with customers to build solutions, do designs, ultimately the things that make their IT infrastructure work. So I head up all of the SEs at EMC. That's like 4,000 people around the globe.
Wow,
Nerds like me that work with customers.
wow, that's actually 4,000 people. That's a few startups together with only engineers. So first, a short disclaimer here. I'm not getting paid by EMC to do this thing.
That's not true.
But I
No, I'm
no,
joking. I'm joking. I'm
yeah,
joking. I'm
yeah.
joking.
I wanna play this straight as it has to be. So we had the EMC Speed2Lead launch early September, and I was one of the people, bloggers out there that had some comments on the release, not only on the way it's released, but actually also on the things that were in there, and. As usual, loud and obnoxious, but eager to be proven wrong. And so Chad actually took that challenge and asked me, hey, why don't we do a webcast in which you can ask me any question? So that's what we're doing here. We're doing, I'll give some feedback from what came from the community on the Speed2Lead launch. There were four major announcements in the Speed2Lead. I have my notes here right next to me. First of all, the new VNXe, which is VNXe 2. We'll talk about that shortly because there's a few things that were feedback and we want to have Chad's opinion on that. The second thing was some software announcements. AppSync, which is a data store based replication with application integration, and Extreme SF, which is server-side PCIe flash. I'm not going to focus on that, but I will focus on the next two parts, and that's actually where I wrote a blog post on, which is the ViPR went GA last Friday now, so the ViPR announcement of GA, and then Project Nile. That's where I wrote a blog post on. So those are the things. First of all, I want to go into VNXe. Chad, we had so the biggest thing in VNXe 2 was actually not mentioned on stage, but it's the change of the operating system from Flare to MCX. And what it is a multi-core operating system, which was not previously. Previously, each core had a specific task. Now it's scheduled, and it's a multi-core operating system. So the biggest comment we get from the industry, and actually it's not only my comments. I looked around, and everyone says the same thing. It is, first of all, long overdue. NetApp did this a few years ago, and I mean, I think that it might be the last platform out there that needed this change or upgrade. And one of the quotes that I found was, "This just fixes broken stuff in a 1990s era platform." So, although long overdue, that's my comment now. So first of all, long overdue, and secondly, it is long overdue, but it doesn't go beyond what we have already in the industry. So for me, it's not a differentiator, and it don't always have to be competitors. I mean, it don't always have to be startups. I think a lot of the major players already are at a level where VNXe is coming now. I think this is a pretty harsh comment for EMC. Chad, I'm going to give it to you to give your answer to. What's your answer to the long overdue and it's close but not good enough for us?
So, thank you for the question. So, there's portions of that I agree with. Because I always wish that we could do things faster. I always think everything that we do is overdue. I do vehemently disagree with everybody who says everybody in the industry is multi-core. And here's the important distinction. and again, I don't want this to be a point where I'm trying to make a negative argument against EMC competitors, right? It's not about them, but it's about correcting, I think, perhaps some of the things that you're incorrect on. All of the competitors in that mid-range space that are mature, large-scale competitors, so most notably NetApp, don't truly have a multi-core architecture in the way that MCX is architected. And by the way, neither does VMAX for that example. Like, just, you know, again, to point out, like, not that I'm being negative against one person, but to make the distinction over what is the revolutionary part of MCX and how it uses multiple cores. Almost everybody else who uses multiple cores, and this was true of VNX2, like meaning the VNX prior, would use multiple cores in the system, but the way you would use a multiple core in the system would be to assign a thread to an individual CPU core. It also meant that you couldn't use the fact that in modern NUMA CPU architectures, the memory bandwidth between CPU cores is much, much, much higher than the bandwidth that we saw in previous generations worth of CPU architectures. So the thing that's new is, if you think about any storage stack, it has elements that are used that are very low level. You've got ones that are used higher up in the stack. As an example, the basic I/O stack, which is basically about draining the block pool and committing it out to whatever persistent media is there, whether it's flash or magnetic or whatever, is slightly different from the chunk of code that deals with the metadata operations. The metadata operations are what are used for any sort of thin or snap or dedupe operations or anything along those lines. And then on top of that, you have other data services that are used for other functions, file system operations and things like that. Previously, each one of those functions of code would always be bound to a thread, and that thread would get bound to a core. And by the way, for anybody who's watching who understands how these architectures work, if you go and you take a look at any NetApp filer and you go and you take a look at the CPU utilization across all the various cores, you can see that they get assigned off to various piece parts and functions. What's different in MCX is that literally any one of those processes is time sliced, like in a hypervisor-like fashion, across any number of cores that are inside a system. That is very, very different, Hans, than what's existed out there before, and the proof point is very simple, which is that the number of IOPS that can be driven through the exact same hardware architecture. In other words, if you take a look at a FAS 3250, you know, that would compete with the low-end VNX and a high-end FAS 6000 type platform. And you look at what's the amount of bandwidth and IOPS that can be driven through that platform and compare it to VNX, the VNX is about 3 to 5 times faster in those core metrics. The last thing that is important about that is to understand it's not just about being big. It's if you can deliver an IOP at $1 per IOP or $1 per gigabyte, which is 2x or 3x lower than what the market currently bears, right? That is a radically new architectural model that's out there for customers to choose. And that is a fact. And by the way, that was one of the other things that, you know, was a big discussion on the online community, which is people basically fell into the category of saying, bless you, you all right? Fell into the category of going scale up versus scale out architectures. And the answer is that basically scale out architectures have certain advantages at certain scaling models. Scale up architectures have got advantages in a different place, usually around the economics of dollars per gig and dollars per IOP. So, you know, I would say at the most basic level, every storage vendor has been shipping hardware that has multiple cores. That's been true for eons. Every vendor has been having software stacks that can use multiple cores in some fashion, right? It is a radical new thing to look in this space where you say every function on the platform can be shared and sharded across all the cores in a NUMA system.
Mm-hmm. So I do get that, and you actually come right into the second question I have there, is that with the new operating system, even on the same hardware, you're running X amount now of operations. So the second question we had from the community is, although it's actually in theory only a software upgrade, why is there no upgrade for existing customers? And I'm not talking about old existing customers. I'm talking about the ones that bought a VNX last year. They will have a forklift upgrade. There is no plan today. So they're asking, what's the deal here? Why, if this is a software upgrade, why am I not upgradable?
Yeah. So it's a good question. And ultimately, the market decides whether or not EMC is making the right design trade-offs. And that's true of anybody. You know, and VNX has been the most popular mid-range platform in the marketplace for its existence, and here we are, we're recording this at the end of Q3, and I can't comment, you know, before we announce publicly, but I can say that every VNX, next-gen VNX that we're manufacturing, we're shipping. Initial customer and partner reaction has been very, very good. What goes into a design trade-off like that is, at one level, very, very basic. So basically what goes into every design is fundamentally a set of trade-offs, right? First things first, I want to be very blunt. Existing VNX customers are going to get free additional capability on top of everything that they originally bought their VNX for. In other words, when they bought their VNX, they said, I'm buying a set of capabilities, I'm buying a set of functions, I'm buying it to serve this workload, and VNX customers are some of the happiest customers in the world. On top of what they got, they will be getting free software upgrades that double their NAS performance in terms of IOPS and in terms of latencies, particularly in VMware and in Oracle on NFS workloads. Free software upgrade. Number two, they will be getting the VDM code. So the virtual data mover code now enables the ability to take a data mover and non-disruptively migrate from one head to another, or alternatively to an entirely new platform. So from this point on, you can do completely non-disruptive upgrades for all NAS workloads. That's a cool thing, and it's a free software upgrade. The other thing that they'll be getting is a lot of the code that was used to improve the Xcopy operations on VNX, which VNX always could have done better on than it was doing originally, is being backported to INYO, which is the code base that currently the VNX customers run, right? So that is good, right? Now, the question is, why don't we backport everything? So why don't we backport the core MCX code? Because the MCX code, which is the thing that gives the block dedupe, dramatically improved TLU or thin LUN performance, the active storage model, which again is a first in this kind of mixed mid-range platforms. NetApp certainly doesn't do that. The only alternate thing that kind of does something like that is something from HTS, their AMS platform. The reason that those are not backported comes down to a basic question, which is the memory footprint that is inside each one of the platforms. Memory is, for almost all modern storage subsystems, the thing that gates their feature, function, and performance. And by the way, like anyone who uses VMware is familiar with this, right? You have lots and lots of CPU, your CPU utilization is low, you usually end up being restricted on storage bandwidth, network bandwidth, but memory more than anything else, right? The reason that memory is so important in modern storage subsystems is they do misdirection for everything. So in other words, there's no such thing as a direct I/O anymore. All I/Os go through a metadata, look up against a table, the table's held in memory. As soon as you have to dump any of that stuff from memory down to disk, performance just absolutely tanks, because you have to then do a on-disk lookup for any in-memory function, right? By the way, that's why, you know, with things that are even more metadata dependent, things like Extreme I/O, for example, the amount of system memory in each one of the nodes is enormous, right? So the core question then becomes, can we jam the metadata functions into the existing memory footprint of the current gen platforms? That's one design decision.
Even the last one, say generation now -1.
Yeah, and if you take a look, basically the generation -1 has half or less of the memory footprint in a given unit of scaling target versus the current generation hardware, right? And to be clear, if you mess this thing up, what ends up occurring is that a customer has a platform that's working in an existing bounded environment, right? You do an upgrade. The upgrade changes the metadata structure such that it's expecting a relatively larger metadata structure versus the same data set. All of a sudden, they see a performance degradation, not an uplift, not because the code isn't better, but because the metadata is being paged out into some other persistent memory footprint. That's one way you can screw it up. The other way you can screw it up is that basically storage stacks, when you have a bug, is brutal because it's persistent. This is why it takes a lot of time for storage stacks to mature. And therefore, if you take a look at it, we have to double the amount of testing footprint that we would QA the new code through. The only way that, and I've been poking at this with engineering, that we could change this on a go-forward basis would be to double the memory footprint versus what we think we need in the current gen, right? Which means that, hey, there's even more memory footprint for future target. So as I poked at that, I asked them, like, what does that do for the COGS, the cost of goods sold? Like, in other words, why scrimp? I mean, if we're currently putting, call it 48 gigs of RAM in a platform, why not put in 96? And the answer is that the memory in those footprints basically would double, it would basically push the cost of goods sold and therefore the price of the platform up one bump. So in other words, what you would currently pay for VNXe 5600 would become the same price point as like a VNXe 5800.
You could be outpricing yourself of the market.
Well, and it's really basically saying, you're targeting every platform to try to hit the sweet spot of what the customers are going to want. Right? That's the trade-off, right?
Okay. So to wrap up, MCX is not upgradable on current, even not the last VNXe controllers, and the trade-off there is not enough memory in those controllers to run MCX performantly enough in your case. Okay. There is a last comment.
No, but hang on, that's not the correct wrap-up. Existing VNXe customers are getting a free software upgrade that brings a ton of goodness for them on top of what they already have. Not everything that's in the next gen VNXe.
That is your marketing answer to my question. The question was, can current customers upgrade to VMX?
That's not marketing. I told you very specifically which chunks of code, VDMs, non-disruptive NAS mobility, double their NAS performance on their current platforms for VMware and for Oracle on NFS use cases, and huge Xcopy improvements. And remember, it's like basically if you bought a car, right, that you've been using now for a year or 2 or 3 years, and somebody said to you, oh, I'm giving you a free upgrade that basically improves some part of the car. It's not the same as someone coming and saying, I'm giving you a whole brand new car, but it's still goodness. It's better than a kick in the face.
Yeah. So we get new tires, but not a new engine. That's actually, there's a free upgrade.
That's not a bad analogy.
No, okay.
So when was the last time your car dealership said, hey, you know what, we're going to send you all new tires for free? A new radio, GPS, Merry Christmas.
Yeah. So last comment on the VNX Lounge is, can VNXF, and that's actually the all-flash member of the family, you got VNXF right now, and we have this thing that EMC bought not that long ago, and we're waiting for something new about it, is Extreme IO. Is that competitive in some place with each other? Because what I'm going here is that, and it's a side comment, and it goes, there's 2 points in this question. First of all, it's the old platform, the 19 eras platform that everyone's talking about. How long can you keep that alive? And is the VNX2 Lounge, including the VNXF, is it not just a point in between the old era and the new era of hardware that EMC has bought? And this resembles a lot to me to the last 3 years that we have been waiting for HP to throw EVA out in favor of 3PAR. And it comes a little bit to that same type of question. So can VNXF be a competitive product for Extreme IO? That's one question. And the second part is, are we in a in-between period of products?
Yeah. So can I tell you something very, at least that I thought was interesting? There was a lot of internal debate in the run-up, frankly, over the last year that said, should we even call this thing a VNX? So just imagine for a moment a new startup arrives on the scene, right? They have a new hardware platform and they have a software stack. And their software stack is very rich. It does block, it does NAS, it does all sorts of stuff. It does a set of capabilities. And through its core functioning, basically has got double or triple the performance envelope of anything else in their price class. And it was called razzmatazz, right? It would mean certain things to certain people, right? I was actually in the camp that we should actually change the name completely. Not just because of marketing, but because of exactly what you just said.
Because it's not a CX anymore.
It's been around since the 1990s. It's true that basically the core Flare stack held up very well through the 1990s. It held up well in the early part of the 2000s, and then it started to show its age at the end of the 2010, kind of era, right? It became increasingly hard to add rich data services to it. Its performance envelope, particularly around things that involve lots of redirection, thin, dedupe, xcopy, those sorts of things, start to show their edges, right? We rewrite the whole core engine of the thing, and we have a debate. Do we call it the same name? And in the end, the winning argument was to keep the name the same. You know why? There's more than 150,000 VNX customers out there that love their VNX. Love it. And again, like these, the most successful of the new startups to date has been Nimble. Nimble has they've broken 1,000 customers. 1,000 customers, right? Which is great. Just to be clear, between the NS platform, the VNX platform, and the CX platform, all of which have got long, long support cycles, there's more than 300,000 out there, right? So whether we should have renamed it or not is going to be something, again, it's up for the market to decide, right? But it's certainly not, a question of does the code stack compete with more modern architectures that are coming out, because it is fundamentally a modern scale-up architecture, right? That's the distinction that's very important to note. Now, if you take a look at it, inside the all-flash world, you have violins and RAM SANs, right? Mm-hmm. That's one class of all-flash array vendor. And it's been fascinating to see the market reaction to the violin IPO yesterday. Did you see that?
Mm-hmm.
Great.
Come on, we don't have to go there, right?
I'm just saying what it highlights is how difficult that new marketplace is, right? But the RAM SANs and the violin focus on performance above all else. Low latency performance, no data services. Agreed?
Yeah, absolutely. Right. No, this is not a violin. I agree
with
that.
No, agreed. I want you to understand basically, like, there's a window of customers and use cases where they say, I want a high availability thingamabob, and my primary buy criteria is how many hundreds of thousands of IOPS within how many RU and at what price. That's their criteria.
I know, but that's not what we're here talking about.
No, just. And then there's another set of all-flash startups out there, Pure, Nimble, and Extreme IO falls into this bucket, that focus on how could we provide rich data services using all-flash as our design target. Those are two very different things, right?
So let's
Extreme I/O.
assume we know in which market we're playing. The
Yep.
question comes now to VNXF versus Extreme IO. How big is that going
Bingo.
to be a
And
problem?
and basically what that translates into is if you need an IOPS machine with a HA profile but not a boatload of data services, VNXF is that. And it can do it in a denser footprint and at a lower cost per U and per IOP than Extreme IO can, or Pure can, or any of those other category of folks. It competes with Violin and with Ramsan. Um, in the category of I want something that can do the new types of data services that these all-flash arrays do, things like inline dedupe, things like a scale-out architecture, VNX will never get there because it's not its design point, right? And basically in that case, as Extreme IO GAs, and it's going to GA extremely, extremely soon, the customer feedback, we've now shipped more than 100 Extreme IO units. Again, for perspective, right? I mean, that means that we have, even though it's a non-GA product, hundreds of customers that are using the product today, right? We have a higher mark that what's expected for our brand than a startup. People have certain expectations from EMC, so we have to wait until we beat on it, until we can support it, until we can sell tens of thousands or hundreds of thousands of them around the globe. As that GAs, I expect that it will very rapidly be the leader in that product category, right, of next generation all-flash arrays.
Yeah, well, let's see what happens there. So
We'll see.
to wrap that up, VNXF is going to play in that all-use lower but market, but mid-sized market where you need some like better performance in Extreme
Performance, no glitz.
Yeah, okay. And Extreme IO will then play in where you really go for the performance and scale out.
Where you want performance with rich data services.
Yeah. Okay. So I think we've said enough now on the old platform. I'll keep calling it that way. No, so we've had VNX2. I think you mentioned a few good points. So let's go to the last 2 points. We have ViPR. Very short on ViPR because there's nothing really new, I guess, in the announcement. It was just a GA announcement. Can you wrap up shortly, in a short notice, what is ViPR? I call it a storage protocol gateway. How far am I off here?
I would say a little bit off. So it's a storage control abstractor. Right? So in the land of storage, there's a mature idea out there called storage virtualization. Right? That idea is not a new idea. In storage land, it means something fairly specific. Within an array, you have the ability to create pools where the storage objects are abstracted. They're not sitting on this disk or that disk or that disk. Across arrays, you put something in front of it that basically abstracts it out so you're managing through it. HDS, NetApp, vSeries, vPlex from EMC, SVC from IBM, all fall into that category.
Is that all going to be, so it have to be products that are on some kind of hardware compatibility list?
Yeah, so basically all of those things are storage arrays that sit in front of the storage array. In other words, you have some sort of existing storage subsystem, it presents up some sort of storage object which is then consumed by this hardware platform with software and then represents it outward northbound. Does that make sense?
Yeah, absolutely, it does make sense. Now, it is also S3 Atmos and Swift compatible. What's that point there?
I just want to be really, really blunt. What I just described is storage virtualization classic. That's the classic definition of storage virtualization. Now, if you think about what that means architecturally, is that you're sitting inside the data plane. Every I/O comes in, gets terminated on this thing in the middle, and then that thing in the middle basically writes it down to some storage media.
Yes.
In other words, whatever the characteristic is of the thing in the front, in terms of its scaling, its data services, its APIs, that's now the set of data services, scaling, performance of everything. Make sense?
Yes.
There's nothing intrinsically wrong with that idea. But that's very different than what the idea of what ViPR brings, which is basically a control abstractor. So ViPR has two pieces, two very distinct pieces, the controller and the data services piece. They're literally two separate VMs. They're decoupled. The only thing that they have together is they have ViPR in their name. You with me so far?
Mm-hmm.
The ViPR controller is literally the exact analog of what NSX does for networking, but for storage. It sits on top of your existing physical data plane of storage, whether that's virtualized or whether that's a standalone array or whatever, and it turns it into a big logical pool out of which you can provision block, NAS, directly by going into the ViPR layer. So it gives a common API, it gives a common programmatic model, and allows you to create logical arrays, logical pools that might be underneath multiple different arrays or one array.
And different types of arrays.
And can be different types of arrays as well, so heterogeneous storage models. That's the ViPR controller, and if you ask me, strategically, that's the most important part. The reason it's strategically important is that people who don't do storage for a living often fall down the path where they go, isn't there just going to be one architecture that ultimately is the right way to do storage, whether it's EMC or not? And the answer is no. Since there's so much workload diversity, at one end you're going to have architectures which are distributed commodity COTS hardware stacks. You're going to have scale-out arrays, some that focus on flash, some that focus on NAS. You're going to have these two-headed things that are the sweet spot of multi-purpose, Swiss Army knife, do many, many things, although none of them do the best out of all of them. That's the VNXe and the FAS categories, right? And then you're going to have some architectures that are designed for any number of failures, don't change the envelope of the platform as a whole, which is the land where you have things like VMAXs and HDS and stuff like that. The moral of the story is, for the indefinite future, we will have a wide variety of hardware and software architectures in the land of storage. The problem is that if that's fundamentally true, how do you make it simpler and easier to manage, automate, and integrate at very large scale? There needs to be an abstraction of the control of all of those storage architectures out from the architecture themselves. And if you think about it, that's what NSX does. Underneath NSX in VMware land, you could have Cisco, Nexus, Catalyst, you could have Arista, you could have anything you want. And basically you could punch, a layer 2 connection, a tunnel between them, and establish a logical network around the edge.
As long as they support those protocols.
And by the way, it doesn't even need intrinsic support because the tunnels with NSX are being done from virtual switch to virtual switch. So the ideas are very, very analogous. In the land of storage, I would argue it's almost even more important because customers have very complex multi-vendor, multi-architecture storage environments, and that's not going to change except for in the market segment where customers want one thing that does it all moderately well, which is that segment that VNXe and the next-gen VNXe dominates.
I like the fact that you use the word moderate in that. Does it all.
Well, so by the way, the definition of anything that does everything means that it doesn't do any one of them as well as a purpose-built thing.
Exactly.
Right? So now the other half of ViPR is the ViPR data services layer. And what that says is it says increasingly, bit by bit, we're seeing more and more architectures come out where you can have the data plane be software only. Right? You can have software only block stacks, software only object stacks, software only NAS stacks. Right? Each one of those has got a varying degree of difficulty. Right? The block and the NAS stacks, since they're a persistence layer, are a little more difficult to get right. And EMC has our own software-only block stack in Scale.io now. And you can expect to see a software-only VNXe in the relatively near future. There will be a software-only vPlex, which is a software-only version of one of our block data services. There's already a software-only recover point, right? But certain architectures, like at the high end, the VMAXs, are very difficult to make software only, right? The place where we see the earliest adoption of software-only storage stacks are in the object world, right? S3, Atmos, Swift. And so ViPR's data services day one includes a Swift, S3, and object and Atmos compatible object stack.
So that's the second controller then.
You can think of one as controller, one data service.
Yeah, okay.
Each one of them, by the way, is a complete scale-out stateless architecture. It's really cool. Like ViPR was developed organically, uses a Cassandra-based distributed database, so each node is completely stateless. You can bring one up, you can kill it, whatever, and that's true for the controller and for the data services layer. And just, you know, again, this is a weird idea, but most people, when they think of the storage landscape and the storage players that are out there, think in terms of enterprise, small, medium business, and SME, right? And they don't think in these massive object stores because that's not how people naturally think. But there's way more storage already in these object stores than there is in all of the traditional storage enterprise market by capacity. If you think of Facebook, which, you know, people use every day, when you think of people sending out twit pics, when you think about doing a transaction on eBay, when you think about downloading a song from iCloud, right? I won't tell you which one of those use EMC Atmos, but a couple of them do. And a couple of them use them in incredibly large scales. Scales that, you know, dwarf our largest enterprise customers. So the idea of a software-only object stack that's open, extensible, and available for everybody is pretty cool.
Yeah, that's, well, and does it scale down? That's actually the, yes, it does. Do you, well, if you say you get these two VMs, they each have their own service, do they need each other?
So you currently, you know, you start with a ViPR controller. You need the ViPR controller to use the ViPR data service out of the gate. It's not really intrinsic, but that's how we design the product.
Okay, but you do install them. Do you install them two per host?
No,
or you just install two from each one.
They're VMs. So basically, it's a virtual appliance. You import the virtual appliance into vCenter or into whatever your hypervisor is, and they're designed basically to be deployed in units of three or more. Right?
Of both.
Yeah.
Okay.
And one thing that's going to be really cool and kind of fun to watch, because I have no idea how this is going to turn out, is we know for ViPR to really become an industry standard, it has to be very open, it has to be very extensible. NetApp has actually been a very good partner for us throughout the development of this. So day one, ViPR will support full support for the FAS platforms, which is great. Lots and lots of happy NetApp customers out there now have this additional choice that they want to use. It'll support everything in the EMC portfolio, so all the primary storage platforms and all the additional stuff, backup platforms, backup, replication, all that sort of stuff. HDS has proven to be a little less interested, right? But what we're going to do is we're going to publish all of the code examples of how to build an array adapter, like the thing that plugs into the underlying array. I think that it'll be interesting to see how many software startups or storage startups jump on that bandwagon. You know, to go, like if you think about it, if you're a smaller company, it gives you an access vehicle to a larger market, right? So we'll see whether startups pick it up. We're going to have to obviously publish code examples of how to write your own data service, because we want this to be a platform where maybe some other companies want to build their own data services. Maybe somebody else will build a ViPR NAS stack, as well as the one that EMC produces. And then the last part of it is that we know for it to become an open standard, we not only have to publish all the APIs, but we need to build some way where people can download and play with ViPR. So it's now GA, you know, and we've got actually our first few customers that have all bought it, which is very fun and exciting, even though, you know, GA'd on Friday and today you and I are talking on Monday. So thank you, customers. But we're going to let it kind of play out through Q4 with a lot of hand-holding of our customers to make sure the code is stable, that they're getting a great experience, all that stuff. But starting in the beginning of next year, I think you can expect to see EMC do a lot of stuff where getting access to play and use and leverage ViPR will be a zero speed bump experience.
Well, now that it is GA, I can't wait to have my VExport NFR license of ViPR.
what I'm telling you is there won't even be an NFR. You'll be able to download it from EMC.com. Merry Christmas.
Yeah. Okay. Let's see about that. Well, it's going to be trial, right?
No. Imagine that. Imagine if you could have something no time bomb.
Let's see. What a Merry Christmas is that? Up to the...
By the way, just to set your expectation right, that's not going to happen right away. Again, we want to handhold the first few thousand customers, right? But stay tuned and look forward in the beginning of the new year.
Mm-hmm. Okay. There's a lot of information already out there on ViPR if you want to go in there, because it is a GA product. Technically, everything should be already available. Yep. Now, we have the last announcement, the fourth, which is Project Nile. And that's the one I wrote a blog post on, because both in the presentation and in your blog afterwards, there was nothing. Literally, we couldn't get anything out of there other than...
I'm glad you're curious.
Marketing. Well, I waited because we had some complaints about the speeds and feeds of the first one of the VNXe, and you made a really good blog post, not going for the 1 million IOPS in your blog post, but showing this is what the VNX1 does, VNX2 does, and I was waiting for that for a blog post of the fourth one, and that went with the Project Nile, and there was nothing in there. So what was in your blog post? It said that it is based on the model of the EMC VMAX Cloud Edition, where you can buy just X amount of bronze, silver, or gold. But that's the only thing that I get out of there. So my comments on what I could read in your blog post is that Project Nile is not a product, but a sales model. How far was I off? Because there's nothing out there.
So just to be clear, right now it's a project. Until something has a well-defined set of packaging and all of those sorts of things, it's not a product. Now, just to be clear, Hans, this is a classic mistake that I make as a technologist, is you look at it and you go, the thing that defines a product is the goop that goes into it, not how it's packaged for you as the buyer. That's not a correct statement. So for example, if you think about a VMAX Cloud Edition, a VMAX Cloud Edition is literally just a VMAX with something in front of it, which is technically a ViPR precursor, right? In other words, a portal that abstracts the provisioning and provisioning services and provides a multi-tenant chargeback mechanism and automation of provisioning, right? It's a precursor in the sense that it's not a scale-out cloud architecture, number one. Number two, it was attached directly just to the VMAX, as opposed to the idea of ViPR that takes that idea of abstraction out and makes it multi-array, multi-platform, and has an architecture which is software only and designed to scale out, right? Now, if you think about what we would need to do as a company to package that up, because the package includes in VMAX Cloud Edition this idea of you don't buy spindles and engines like you would in a VMAX. You literally say there's 17 different SLA bands, bronze 1 and 2, silver 1, 2, and 3, gold 1, 2, and 3, and so on and so forth, right, all the way up to platinum 1, 2, and 3, right? And each one of those has got a price tag in terms of the amount that you're using, not how much is actually underneath the covers, right? The amount that you're using, and underneath it there's a whole bunch of logic that says when a customer orders X, we show up and we deliver one engine and this capacity and this disk configuration, but they never see any of that stuff. So just think about the business operations and machinery that has to go into that, as well as being able to have all of the systems such that when they start to consume that capacity, we ship out the new capacity, including new engines if necessary, right, to provide the support for that capacity. Now, in the end, the hardware in it is a VMAX. So all of my SEs, right, the technical people like me and like you, look at it and go, I don't get it. But a customer immediately looks at it and goes, one is a capital purchase, a VMAX. One is an OpEx purchase. One is one where I have to size for future demand. The other one is one where its value proposition to me is it's coming to me as a utility, and I pay for it as I use it.
So it is right? Like I explained in my blog post, the Coca-Cola model. You just say to Coca-Cola, put a vending machine in my office, and you come and replace it, or you put more in if we use more. So you are buying, if I want 30 terabytes of bronze, 20 gold, and you're going to put enough spindles in it, and when I need more performance to get to that gold level, you're going to monitor it and give me more?
Yep. And not just the spindles, but actually the engines too, right? Because, obviously with the storage subsystem, there's the persistent layer, but there's also the brains and front-end ports and bandwidth and all that sort of jazz, right? So the experiment that we had in VMAX Cloud Edition, and when I say experiment, it's not an experiment, it's a shipping product, right? Customers have indicated very much that that's a model that they like. That's how they like that idea. Now the problem is that VMAX Cloud Edition has a list price per gig of bronze of $3.60.
I know. I got it in my notes here.
Right. So,
but that is to be clear here. That is used capacity, not usable.
Used capacity, and also on a 3-year model. In other words, even though you don't pay for it, year by year, that's basically saying, okay. By the way, there are a bunch of little caveats that are important for everyone to know, which is that for each block, there's a minimum. So, for example, with bronze, the step function isn't completely linear. Like, I think the minimum step function for bronze is 10 terabytes, right, in a VMAX Cloud Edition. And if you think about it, all of those step functions are partially tied to architecture, but also partially tied to business, because EMC is shipping them a VMAX, right, with a single engine, right, initially with the capacity for bronze. And we take on the risk. It's literally, the capital is still on EMC's books, right? It's not on the customer's, it's on the customer's books, right? So what Project Nile does is it says, take that idea one step further, right? First things first, you could scale it up in a model that was much larger scale and simpler now that ViPR is GA. Because ViPR represents the abstraction model of how this actually gets provisioned underneath the covers. And historically, we had to use a VMAX as the core scaling engine behind this, because in the VMAX case, you can add engines, up to 8 engines, right, before you need another VMAX, right? And the management orchestration layer was tied to the VMAX. You can now imagine that with ViPR, it would be possible for us to package up 100 small VNXes that could offer a bronze-like IOPS and dollars per gigabyte that would be below $1 per gig. And that basically is the power of MCX applied in a different way. We were able to have an extremely dense IOPS and gigabytes machine that doesn't scale up or scale out from a management perspective. To be correct, scale out from a management perspective. But if you front-ended it with ViPR, you could have many, many of these things that in essence provide an aggregate pool. And since the process of adding one would be as simple as like a $10,000 cost of goods sold, meaning a small little unit that just plops in and you continue to manage it, it would mean that we could even scale down the step function of how you consume the storage. Does that make sense?
Yeah, absolutely. So what we're saying here actually is that Project Nile, so I was kind of correct that Project Nile is a sales model with any products in the back end and ViPR in the front end, and that sold as a utility model.
Yes. The only thing I would correct is it's not just the sales model. There's a ton of business operations that have to go into the platform, literally constantly updating headquarters of how much is being used, so we're constantly shipping capacity as needed, right? Ultimately, that's what people want if they want to have an experience that is better than Amazon EBS on-prem, right? The upside of EBS is that you don't need to know anything about what's underneath the covers. You literally just go, I want more EBS, elastic block storage, right? The downside is that it has to be attached to an Amazon EC2 instance, right? You're not going to drag an EBS connection out to your on-prem workload, right?
So the product that is in Project Nile would be services.
Yeah, in the end, it would be storage as a service.
Yeah. Okay, I think I kind of get it. I mean, there is no product. It is a sales model, but it adds the services. Maybe that comes to one extra question: is how would this relate to the partner channel? Because EMC has a big partner channel. Mm-hmm. Are they going to be able to sell that?
Absolutely.
Because it's going to be EMC that is going to monitor and do the extra services. Yep. Are the partners going to do these services or not?
The answer is yes. So Nile will be available to everyone who is an EMC partner and channel, right? And it's not as big a gap. It's not as big a change as you think. Like even today, when somebody sells a VNXe to a customer, and VNXe is very, very popular in our channel, there's something called ESRS, which is the EMC support, remote support utility that basically connects up to EMC and sends us performance and health status and stuff like that. And it basically presents it in a portal that the partner can actually see themselves. So the partner logs in, they can see the health of their stuff, even though it's being aggregated up by EMC. What's likely with Project Nile is that as it becomes a product, we need to work through between now and when we talked about it at launch being early next year. Obviously, think about it now. Now that you can picture it a little bit better, there's got to be this dial home capability. But if it was going through a reseller, right, and a partner, a VAR, the person who needs to get informed over more capacity needed isn't the end customer. It's probably the VAR.
Yeah, absolutely. I get that. The only difference here is that it comes when they do that today, the call home or doing the services today, they will look at okay, you need more, but it's going to be a capex expensive instead of an opex expensive. That's a difference between how they do it today and how it might be done in the future. I think I got it. I think I understand what the idea is behind it. I will follow up on that. I like that idea. I like the Coca-Cola principle, as in, okay, we'll do the maintenance of your hardware. We will exchange controllers when necessary or disks when necessary. I think there's a big market out there for something like that. I do have some final closing comments that come to the event as such. I cannot resist to ask these questions. There's two in there. First question is, why was there nothing about the new platforms being ISO and Extreme.io in the whole presentation? I mean, Extreme.io hasn't even been mentioned once in the whole presentation. What happened there?
So like any company, right? I mean, literally, like look at Apple, right? They just did their iPhone 5 launch, right? September. Exciting. I can't wait for my iPhone 5S. I'm actually pretty happy with my iPhone 5 as it stands.
Do you want to see with a color on the back, a blue one?
Yeah. So, but the point is that everyone knows that the iPad 5 is coming probably in October. Mm-hmm. Right?
Okay, so that's why you could just remain silent on Extreme.io.
The key thing is that you can't, as a public company, announce something until it's ready to ship and recognize revenue that quarter. Right? So there's just an important thing. You can make an announcement of intent, but you can't say that a product is available unless it's ready to be, ready to go that quarter. Which is why every team always has to think about, when do you provide a preview to the market to get input, feedback, and generate buzz and interest. When do you basically announce the product, and when do you ship the product? you can generate buzz whenever, but when you announce something as available, you only have 1 quarter to get it done and out the door. So, and by the way, that's why the ViPR announcement was big, right? Even though there was nothing new, when we talked about it at EMC World in May, people were like, "This thing's the rainbows, unicorns, and fairy dust, right? Sounds great, but we'll see what happens." What people didn't know is we've been working on it for the last 2 years, and we knew that we were less than 6 months away from GA, right?
So as there is no EMC World around the corner in Q4, do we expect a GA announcement then at EMC World?
I'm not going to tell you that.
Because you just told me I can't announce anything that will not be released within a quarter, so it's not going to be Q4.
So what we do is we basically try to go and we group our product launches into what we call mega launches. And a mega launch isn't necessarily anything more than one product. We found it's more effective to basically say more than one product at a time, right? And if you take a look back in Q2, we announced a big refresh of a whole slew of stuff around the Extreme SF portfolio, around BRS. There was all new data domain, hardware and software. There was all new software around the backup portfolio. So there was like a launch in Q2 of all that stuff. So it was out, shipped, ready, and we had a great uptake and response from our customers, which is fantastic. Then in Q3, we have this mega launch, which was VNXe, ViPR, Project Nile, as well as some of the smaller software pieces you talked about. And then clearly we have Q4, Q1, and then May. So stay tuned. There will be fun, exciting stuff every quarter. Count on it.
So, and actually you come very good to the last point of comments. And it's actually a big comment out there from, and maybe it's just because we're too close, but the comment was, what's the matter? What's going wrong at the marketing department of EMC? Because how many people can care about an Evel Knievel jumping over VMAXs? How many people can care about 25 dancers propped in a Mini or a Formula One VNXe? It was just marketing, and it was and let's not go marketing all over the top, but your blog posts were the only ones that really went into. We actually expected those type of. If you're doing a marketing event, I don't care about that, but there needs to be information in it, and that was the whole problem. We didn't get any information out of the event. The only information came later that day from maybe your blog posts. So, is there something wrong or not?
No. So I think that there's some validity to your point, and I certainly kind of feel that way. And I told the various people within our marketing team, my view on it, and they did educate me a little bit. There's a lot of truth to what you're saying, which is we're too close to it, right? Storage events. IT events in general have a tendency to be pretty darn boring, right? Particularly for people who are not part of the cognoscenti, the people who are the people on the inside, right? And storage events, can take it to another level where literally they're, more boring than watching paint dry. I think that, so by the way, all of those stunts and gags and over-the-top things are wildly popular. Wildly popular. Maybe not with you, maybe not with some folks, and I hear that. And I kind of feel the same way a little bit in the sense that I don't entirely get it, right? I think that they're fun, and I think that might be the point. Some people find them fun, silly, whatever.
Well, it can be fun. I mean, I can have fun, but if it's only fun, and we're missing the whole point that there's no information whatsoever, then you have a problem.
I think that was the thing. There's always an ability to improve on anything you do. I think that that part of your feedback is good for us to incorporate. I think that it was too light on the ability to go deep, on certain pieces of content inside the launch and after the launch. And I think that that's something. Stay tuned. You'll see us get better and better and better at that. But don't expect us to slow down with the silly.
No, I get that, but the whole point of comment here is, for example, MCX, the it hasn't even been mentioned, and that was the biggest news on that whole VNXe announcement, that it has been redesigned, and the only thing we heard was speeds and feeds and IOPS and latency.
Yep.
And we got 1 million IOPS. Well, I mean,
it's funny because basically I gave, feed HUA, heard, understood, and acknowledged, right? I think that we could have done that component of that event better. I also think that certain things that we did that basically were punching down against some of our smaller competitors, I think wasn't my cup of tea.
Okay. Thank you for that acknowledgement. Punching down is never necessary. Not even punching up should not be necessary. But the punching down, if you are the market and like market by X amount, it was slightly over the top. But I mean, some people still found it funny. It was kind of funny, but not necessary.
Yeah.
But let's keep it there. I like some of the acknowledgements here. And I sincerely hope, even if on stage goes still against our will, how you ever want to call it, please make sure that the information we need is available somewhere. And I hope that maybe your blog posts there was plenty of information in that first blog post on VNXe. I like that. Together with the blog post of StorageZilla that we had throughout the day, where we say, "Oh, it is a rewritten code," and then so we're following this live with a few hundred people. There's a lot of bloggers out there, and everyone was so disgusted that there's no information. And if the information comes along with the jumper, I won't watch the. Then I have the opportunity. Then I have the opportunity not to watch the jumper and read up on the information.
Next time we'll have the jumper jump out of a plane, wear Google Glass, come into your apartment, and hand deliver the blog to you.
I know you could pay for it.
Hans, listen, man, thank you so much. It's been a pleasure, and I'm happy to get on a Google Plus Hangout with you anytime, dude.
Yeah, Chad, thank you for the feedback. I think I gave you the time you needed to do this, and we're all about information, man. That's the only thing we care about. And Chad, I'll probably first time we'll meet is going to be in less than 2 weeks, VMworld Barcelona.
I can't wait.
And even after that, I know that you are going to join me for VMUG Denmark and VMUG Belgium in December.
We'll have lots to hang out and talk. And plus, off the record, I'll give you even more information.
Chad, thank you very much. See you next time.
You got it. Thanks.